The temperature of the substance is the average of the kinetic energy that is possessed by the molecules. It's a reference of the thermal energy that we have. And we usually are measuring this with a thermometer, which it can be either with a resistance thermometer, a thermocouple, or, well, we usually use also the thermal expansion of usually a fluid like mercury in order to calibrate this expansion to yield to a certain temperature. And we have two scales. The scale that we are using in international system is the Celsius, and this Celsius scale is assigned to a 0 degrees Celsius, where there is the fusion point of water, while 100 Celsius is assigned for the evaporation of water. This is not very good, so we have what we call the absolute scale, which is the Kelvin scale, and the 0 Kelvin will fall at minus 273.15 degrees Celsius. Okay. So if you want to turn from Celsius to Kelvin, you need to graph the temperature. So you want the temperature in Kelvin, and you have the temperature in Celsius. So the temperature in Celsius, you need to add 273.15. In the either way, if you want the Celsius, then you grab the Kelvin and you subtract the 273. In the English system, we have the Fahrenheit, which you assign a value of 32 degrees Fahrenheit for the 0 Celsius and 212 Fahrenheit for the 100 Celsius. And the absolute zero, which is called the Rankine, will be at minus 459.67 degrees Fahrenheit. So in order to change from Fahrenheit to Rankine, you will grab the temperature, which is, well, you want the temperature in Rankine, you grab the temperature in Fahrenheit, and you just add 459.67. And remember that Rankine and Kelvin are absolute temperatures. More interesting is to change from Fahrenheit to Celsius or Celsius to Fahrenheit. So the temperature in Fahrenheit will be equal to 1.8 times the temperature of Celsius plus 32. And more interesting also, if you want the Rankine, the temperature in Rankine is 1.8 times the temperature in Kelvin. So Celsius and Kelvin have the same slope, but there is a variation of a slope with Fahrenheit and Rankine of 1.8. And also, Rankine and Kelvin, which are absolute, they are set in the absolute zero, so they share their zero, but the zero in Fahrenheit and Celsius is not the same. And that's the reason why we need to change and add this 32. So if this is the scale in Celsius, 0, 1, 2, 3 Celsius, we can understand that this is 273, 274, 275, 276, 277, and 278 in Kelvin, which means that one step in Celsius, or a change in Celsius, is the same as a step or a change in Kelvin. But it's not going to be the same with Fahrenheit and Rankine when you compare this with Celsius and Kelvin. When you want to compare a step in Fahrenheit, well, it's the same. One step in Fahrenheit is going to be equal to one step in Rankine. And this is because the systems have the same slope. The problem is to turn from Fahrenheit to Celsius when we're talking about steps. So 1.8 Fahrenheit is 1 Celsius. This is only for changing temperatures. 1.8 Rankine corresponds to 1 Kelvin. And also we can say that 1 Fahrenheit is 1 Rankine and 1 Celsius is 1 Kelvin. These are conversion factors, right? So in either way, if you want to turn from an interval, right? If you want to convert an interval, and we say that delta T is going to be equal to, let's say, 212 minus 32 degrees Fahrenheit, right? Well, we want to turn this to Celsius. Then we know that 1 Celsius is 1.8 Fahrenheit. So we cancel this with this, and we can have 100 degrees Celsius, right? Sometimes you have to turn certain conversions, let's say 0.487 BTU per pound mass Fahrenheit. We want it in joule per gram Celsius. And this is a heat capacity, this is CP. And you have to understand that this is dealing with a delta T. So if we need to change from Fahrenheit to Celsius, then what we need to do is we grab the 0.4827 and we do a table as we have already stated before, right? Where we can do our cancellations. And we want to get rid of the BTU. We know that 1 joule is 9.5 more or less times 10 to the minus 4 BTU. So in this sense, we can cancel BTU with BTU and we get only joules, right? Let's say we want to get rid of the pound mass. We know that 1 pound mass is 454 grams, right? So in this sense, we get rid of the pound mass, right? And then we want to get rid, I am going to continue here. We want to get rid of the Fahrenheit. So 1.8 degrees Fahrenheit we know is 1 Celsius, right? So in this sense, we get rid of the Fahrenheit and we get the Celsius. So at the very end, we just have to divide over 9.5 times 10 to the minus 4, divide over 454 grams, well, 454, and multiply times 1.8, and then we get our heat capacity in terms of joules per gram Celsius.